All right, so for number 4, part A, it says find the average acceleration of the train over the interval 2 to 8. Now, there's really two ways to think of this. One, we could find the average rate of change of velocity, because the average rate of change of velocity would correspond to the average acceleration. All right, the other thing that we could do is we could look at this from the integral, like the average value of acceleration formula. So I'm going to look at that first, just because I think it's a little bit the more interesting route. All right, so if I take 1 over 8 minus 2, integral from 2 to 8 of a of t dt, we know that would give us our average acceleration over the time interval. All right, so if I look at this from a fundamental theorem of calculus standpoint, I have 1 over 8 minus 2. Antiderivative of a of t is v of t, and I'm evaluating that from 2 to 8. So I'd end up at v of 8 minus v of 2 over 8 minus 2. All right, now you're going to notice that right there you have your slope on the velocity curve, which would be your average rate of change of velocity, which is acceleration. So you could also realistically start right here at this point. Now, from here, I'm going to go ahead and calculate that. So I've got v of 8. V of 8 is negative 120. V of 2, which is 100, over 8 minus 2. That's a negative 220 over 6. Both of those are divisible by 2, so you have negative 110 over 3. All right, now we go ahead and put it in context. So it asks us for the average acceleration, so we would say the average acceleration of train A is negative 110 over 3 meters per minute squared. All right, from t equals 2 to t equals 8. All right, and that would be the entirety of the answer for part A. All right, I hope that helped.